Yo, welcome back guys. I'm Shrami and this is Advanced Cairo. So this is part 4 and here we're going to be looking at pre-compute for our Miller loop. We will find out what the pre-compute type needs to be for our Miller loop for Groth16 pairs. Cool. So I've written here the placeholder function that will initiate all verification. We can jump into what it takes and what it returns later, but roughly this is gonna compute k from the IC and input and public inputs. Then it's gonna compute the optimized triple mirror loop, which we are writing right now for the 3 points. For the 3 pair of points, which are going to be like 6 points. Then finally it will multiply the pre-computed alpha beta Miller with the pairing, and then it will compute the final exponentiation, and then it will basically return like is the result equal to 1 basically. 1 in terms of FQ12, which is going to be like 1.000, a bunch of zeros, like something like that. But anyway, I'm not going to be typing it myself anyway, so basically it's going to be equivalent to checking that result equals 1. Cool. So jumping on to our pre-compute, let's go ahead and look at what the pre-compute looks like for single pairing. So let's go to impulse and we see that we've got this pre-compute here, and looking at this, looks like it keeps P and Q. So for us, P and Q are gonna be like multiple points because we're gonna do Miller loop on them consecutively. So that looks good. And then we have something called PPC. Let's go ahead and look into this P pre-compute. So here we actually do a neg x over y for P, which is going to be used in calculations multiple times in the Miller steps. And we also get the y inverse. So that looks good. Let's go ahead and try to do something similar. Oh, sorry, I forgot about the remaining parts. So we also do neg q, which is useful for probably calculating the negative bits. And finally, we also have field nz, which is the non-zero representation of our field, which we need for stuff like division and modding and stuff like that. So let's go ahead and copy this, and we will try to start off from this for our Groth16 pre-compute. Let's just say this is Groth16 pre-compute, and P is actually going to be our Groth16 Miller G1, representing all the points that we need. And similarly, our Q and neg Q will also going to be Groth16 Miller G2. Cool, that looks good. Now we need to figure out what to do for our PPC. So we've got like 3 points here. What we can simply do is have a tuple of 3 pre-computes, 3 P pre-computes. And before we do that, we need to import it from pairing, and I believe it's going to be in 8 impulse. And here we just do this, and now we make it a tuple of 3 points. Cool. So with that, our Groth16 pre-compute looks pretty solid. In the next video, we will go ahead and write out some parameters for verify and start to build this so that it's easier to see what's going to happen. So see ya in the next video. Cheers.